This double integration question, which is from calculus 3. So I will use polar coordinates to determine this integral. All right, so dy and dx, we can use Jacobian. If you apply Jacobian, you'll find out dy over dx must be equals to r drt did if you apply using Jacobian. Then, so first of all, I will draw. We know again this inside x squared plus y squared is simply equals to r squared. All right, so let me scratch. I will try and let me do a scratch. Let me scratch. So I want to check here. So here we have we know this is y. We have y equals to 0, y equals to the square root of that. Here we have x equals to minus 1, x equals to 1. All right, so y is equals to 0. We know that y equals to 0 will simply act here on the horizontal. It's acting here. We know there will be there on the horizontal. It's when y here is equals to 0. It's when we have y is equals to 0. That is when we have y is equals to 0. Then y is equals to that. So okay, that is a semicircle and it is positive, it's above. So we know that the radius there will simply equals to 1, isn't it? So we know this will have here minus 1 up to positive 1. So we'll have also here, it will cut there at 1. So we'll have this semicircle there. If we sketch that, we'll cut it at minus at positive 1. Alright, so as you can see, we have now this section. We can have that section. But now, since we have this, we'll go from the x, we'll go from this double integral and go to the polar coordinate. So I will change the variable now. So r, the radius, will simply start from where? Here it's going to be a radius from 0 up to there, 0 up to there. We have the radius, then the rotation will go from 0 up to 1/8, whereby it's what? It's pi. So that means the r must be less than or equals to 1 or greater than or equals to 0. Then theta, as you can see there, it's rotating like that. We'll have theta must be between pi and 0. As you can see from 0, then we take the rotation like that. All right, so we can change now. We can change our integral now, where this will be the integral we'll have now. Instead of, we'll have our integral. So now we'll start from 1. Remember, we still have our, we'll change now. This will have cos, that one will be r squared. Now we have changed this to be equals to that. Now this will be r dr d. So now let us replace our limits, our upper boundary, so we can see that r will start from 0 up to 1, from 0 to the origin up to what? Up to 1. So we'll go from 0 up to 1. What about theta? We see is from 0 then up to pi, will be from 0 up to pi. We have this term. Alright, so as you can see now, we can use substitution. We can able to use substitution there. We can just let u to be equals to r squared. Then you differentiate du must be equals to 2r dr. Then making dr the subject, this will be du divided by 2r. So we can substitute it back there. If we substitute, we'll have our integral 0 up to pi, the integral from 0 up to positive 1, we'll have cos. This will replace, this will be u multiplied by r multiplied by du over 2r multiplied by d theta. This is what we have there. So r and r will cancel. We can take 1 over 2 outside of the integral. I'll have 1 over 2 outside of the integral. We have 0 up to pi, the integral of 0 up to 1. So we'll be left with cos u du d theta. So the integral of this now we'll have the 1 over 2 integral from 0 up to pi. This integral will be positive sine u. Now will be evaluated from 0 up to 1. We still have our multiplied by d theta, that is the inside integral. We have that inside integral. So still have 1 over 2 multiplied by the integral from 0 up to pi. So we'll plug now the upper limit. We'll have sine 1 minus sine 0 multiplied by d theta. So this is what we'll have. All right, this is what we have now. So we have 1 over 2, the integral from 0 up to pi. We have now the sine 1. We cannot do anything. This will be sine 1. This will simply equals to 0. So 0 is nothing. So this will simply equals to sine 1 multiplied by theta. All right, that is what we have. So we'll have to integrate this. Now that is simply just a constant. So this will simply equals to 1 over 2. The integral of that sine 1 is simply just a constant and multiplied by what? By the theta there. So we'll have this to be theta multiplied by sine 1. All these will be evaluated from 0 up to pi. From 0 up to pi. So we have 1 over 2. This will be pi sine 1 minus 0 sine 1. All right, so this will simply just cancel anyway. Will simply just becomes to 0, will fade away. So we'll be left with 1 over 2 into integral of sine 1. So this will simply equals to pi sine 1 over 2. So this is our final answer.